This video is part 3 of our review for polynomials. So let's take a look at number 5. Alright, so looking at number 5, there are 3 key pieces of information that we need to get a good graph going. The main thing, of course, is the zeros. So let's start with that. Can you obviously tell me what are the zeros here? 4, -1, and -3. So let's start with that. Those are definitely the zeros. Let's see. Let me use this color right quick. So 4. So these are my zeros. So I got 1 at 4, -1, and -3. Okay. Now, next piece of information that's helpful to us. The negative sign in the very front. You see that? Okay. That tells us whether it's going to be like right side up or upside down. But the degree. We need to say a word about the degree before we go any further. What is the degree of this function, you guys?
3.
It's not 3.
4.
The degree is 4. Okay, this is very important. Okay, let me make sure everybody understands why the degree is 4. We're basically counting up the x's. Okay, so there's 1 here, there's 1 here, but there's 2 here because it's squared. Okay, so that's why. Like if I took out everything else, if I took out the -4 and the +1 and stuff, what I would have would be x times x times x squared. That's what I have. So that's 4 x's. Does everybody understand why the degree is 4 now? Okay, degree 4. That gives us the shape. So if it's degree 4, do you remember what the shape is?
Yes. It's
Well, a little bit more than problem.
in the middle.
Yeah, it's kind of, like what letter maybe?
W.
Like a W. Okay, in general it's like a W when it's degree 4. But kind of what letter will it be now because there's a negative in front?
M.
It'll be more like an M because of the negative, okay? So that's crucial that we have a model in our minds to work from. So it's going to be like an M shape based on the degree and the negative leading coefficient, okay? One more thing that we need to be aware of. Remember, depending on whether the zeros are single or double or triple, that tells us whether the graph is going to pass straight through the zero or bounce or do that inflection thing where it goes like that. Okay? The first 0, 4, that's a single. So my graph should pass straight through that. Maybe I'll just write down through. I can't do that. 4 is through, all right, like normal. What about -1? That's just through, that's normal. What about -3?
Bounce.
That should be a bounce. Okay, this is key. Okay, because it's a double root, because it's squared, we should have a bounce at -3. So if we put all the information together, we should be able to get a pretty good graph going. All right. So just from that alone, I'm going to do a sketch so far. I might go ahead and use my TI-30 to get a couple points going as well. But so far I have this. Let's see, I want to go through, and then bounce. Ready? So it's going to be something in general like this. It's going to go through that one. Oh, I hit the bounce when yeah, let's pretend that didn't happen. Right, because, yeah, -3 is the bounce. This is my bounce. Okay, let me try that again. So it's going to make this upside down W, so it should be a bounce, and then through, and then through. Okay? That's the basic idea. Okay? And I'm just going to accept that as good enough. If I wanted to get a couple more points to see a little bit about maybe how high the humps go or something, I could put it in my calculator. But I just don't want to go into that right now. That's good enough. Any questions about how we did what we just did? Okay, so that was number something. Number 5. Okay, let's move on. Number 6. Use the table to the right to answer the following questions about the function. Oh, shucks, got this table. Do you see any zeros? If I want to talk about the zeros of the function, how many zeros do you see off the table?
1.
The answer is 2. There are 2 zeros. Name the first one. 3 0 is the first 0 you see. That's a 0. What's the other one? 8 0. 8 0. What about 0 96? Isn't that a 0? What's that? That's the y-intercept. Okay, 0 96 is not a 0. So we have 2 zeros, 3 and 8. Okay, so we're going to use that. Okay, how many zeros are there for this function? Okay, what do you think? How many zeros are there for this function, class? All right, show me on your fingers what you think, how many zeros there are. Show me on your fingers real quick. Oh, I think Brenton is. Hold on, let me pause this. Dude! Let the record reflect that, this is for the YouTube people, most of my class indicated 4 zeros on their fingers just now. Well, I only saw 2 on the chart. Why are you guys saying 4?
Because of the X formula.
Ah, the fundamental theorem of algebra says the number of zeros, if we count any repeated zeros, okay, the number of zeros should match the degree. So the correct answer is 4. There should be 4 zeros. Okay? So we'll just say that the degree is 4. So there should be 4 zeros. Counting repeated zeros separately. Okay, there's your explanation. The degree is 4, so there should be 4 zeros counting repeated zeros separately. Okay. Okay, use the table to find all the roots. Show your work. So it would be silly to give me one where showing your work was just copying down these 2 zeros. So what am I supposed to do to find the other 2 zeros? Synthetic. Okay? Synthetic division. So let's do that right now. Okay, let me write a little smaller. Okay, so what's that first 0 at the top of the chart again?
3.
All right, so the first 0 is 3. So let's start with that. What are my read my coefficients to me.
1, negative 11, 28, negative 94, and 96.
Okay, so we're going to do our synthetic. And those numbers were the coefficients of this polynomial. All right, so here we go. So I bring this down. So I multiply, I get 3. I add, I get negative 8. I multiply, I get negative 24. I add, I get 4. I multiply, I get 12. I add, I get negative 32. I multiply, I get negative 96. Add, I get 0. So I got this so far.
So we put the 8.
Okay? Say again?
We put the 8 and continue with the 8 first.
Yes. We could definitely put the 8 since we have the table and we have 2. We could use the other 0 of 8 and keep going. Does anybody notice anything else I could do as well? James? Yeah, I'm always, anytime I get down to 4, I'm mentally looking at it to seeing if grouping would be possible. Looking at the second pair, imagine that I try to pull a GCF out of this. What's the common factor of 4 and negative 32? 4. If I pulled out a 4, right, it'd be like 1 minus 8, correct? So you can see the 1 minus 8 and the 1 minus 8. Grouping would work on this one. So I could do grouping. But I'm just going to go ahead and use the 8 for now. Okay, but let the record reflect. I could have grouped right now. But let's just keep going with the 8 now. out. Okay, so if I bring this down and I keep going, so multiply, I get 8. I add, I get 0. Multiply, I get 0. Add, I get 4. Multiply, I get 32. Add, I get 0. So now I have this trinomial. What's the trinomial? X squared plus 4. I guess it's not really a trinomial. Binomial. X squared plus 4. Okay? Yeah, so this can't factor any further, so what am I going to do? Exactly. Just go ahead and set it equal to 0 and solve it out. So if I subtracted 4 from both sides, so that's going to give me x squared equals negative 4. What do I do now? Yeah, let's definitely take the square root of both sides. Don't forget your plus or minus. Yeah, I hear you saying because I have a negative under the radical, that's going to be imaginary. Square root of 4 is 2, so 2i. Plus or minus, correct. Yes, sir. Okay. So I have x equals plus or minus 2i. All right, so the complete list is, I've got 2i, negative 2i, and 3, and 8. Okay, so we knew there would be 4 zeros because of the fundamental theorem of algebra, and here they all are. Any questions on part B here? Okay. I guess that was it for number 6. All right, moving on to number 7. Yeah, this video is going to run a little long. Usually at 15 minutes I try to wrap it up. This is going to go probably to 20, a little over 20. Whatever, close enough. Write a polynomial function of least degree that has rational coefficients, leading coefficient of 1, and these zeros. Multiply it out. Okay. Before I do anything else, it looks like I'm giving you 3 zeros, but I'm actually giving you 4. What am I talking about right now? Yes, we learned that imaginary roots always occur in pairs called conjugate pairs. So if you have 3i, you automatically also have a negative 3i. Okay, so we really have 4 zeros to deal with. Let's take each one of these and turn it into a factor. Okay? So, I'll start from this side. From the negative 3i, I will have a factor of x plus 3i. Okay? From the positive 3i, I will have a factor of x minus 3i. All right? From the 0, I have a factor of just x. It's like x plus 0 or whatever you want to call it, but it's, it's just x. And from the negative 3, I'm going to have a factor of x plus 3. So these are my 4 factors that I've got. Right, James? Keep those eyes open, buddy. Are you finished? All right, so I'm just going to do these in pairs. So I'm going to do these 2 first real quick. If I double distribute to multiply this out, this is what I'm going to get. I'm going to have like x times x and x times 3i. So that makes x squared and 3ix, if you will. Okay, and then I'm going to distribute the negative 3i. So negative 3i times x is negative 3ix. Negative 3i times positive 3i is negative 9i squared. So a couple things are going to happen on the next step. What's going to happen with the 3ix and the negative 3ix? They cancel out. So let's get that done. Okay, so these are gone. Okay? Now, what have we learned about I squared, you guys? Yeah, we learned that I squared equals negative 1. All right, we just memorized that. So in that case, what's going to happen to this negative 9? it's going to become a positive 9, all right, once you multiply it by this negative 1 right here. Okay, so in the end, I'm going to have x squared plus 9, like Ashton was just saying. Okay, so x squared plus 9. Now I'm going to do these guys over here on the left. Over here, I'm just going to distribute the x. So if I distribute the x, I'm just going to get x squared plus 3x. So I've got x squared plus 3x. Okay? But I have to keep going. Now I need to double distribute this some more. So if I distribute the x squared, so here I go, x squared, x squared. X squared times x squared is x to the 4th power. X squared times 9 is 9x squared. Now the 3x. Okay, 3x times x squared is 3x to the 3rd power. 3x times 9 is 27x. Is this in the proper order? No, it's almost in the proper order. Remember, we want descending exponent order, so these two just need to be reversed for the final answer. So that's why the final answer is going to be, let's see, I'll use
4 plus 3x.
yes, sir. So f of x equals x to the 4th power plus 3x to the 3rd power plus 9x squared plus 27x. Okay, so that would be the answer to number, whatever this was, number 7. All right, any questions on number 7? All right, that's long enough for this video. So let me stop this video, and I'll pick up the next video with number 8. Oh, long division. Oh, Lord.